All right, in this video, I'm going to give another example of composition of functions. So this is a slightly harder example, but I'm sure you can follow along. All right, so first of all, I need to define my function. So I say f of x is equal to x plus 1. And then I have another function, g of x, which I'm going to actually define as a quadratic. It's going to be 2x squared plus 3x plus 4. All right, so let's do the first thing, which is let's find f of g. Oops, let me just write it a little bit neater. So let's write f of g of x. And what this is simply f of g of x. And now let's figure out what is g of x. Well, it's 2x squared plus 3x plus 4. So I'm going to write f of, and I'm going to replace that with obviously what I see right here. Right? G of x is simply that. So it's going to be 2x squared plus 3x plus 4. Now the next thing is, remember that we're going to take this input right here and we're going to put it right into this x over here. All right, so we're going to take this and put it right into that x over there. So if I go back to the white, this is simply equal to something plus 1. And that's something, because this is f of x, that something happens to be 2x squared plus 3x plus 4. So it's 2x squared plus 3x plus 4. And if I simplify that, I get 2x squared. I can just remove the brackets because there's nothing in front, so it just means everything's multiplied by 1. So it's 2x squared plus 3x plus 4 plus 1. Well, here we can add the 4 and 1. So our final answer is 2x squared plus 3x plus 5. All right? So that is f of g of x. Well, let's do the opposite. Let's do g of f of x. So I'm going to take a new page, and I'm just going to say this is example 2 continued. So CONT''D, that just means continued. So I'm just going to write the functions again. So f of x is equal to x plus 1, and g of x is equal to 2x squared. So it's the exact same equations. You don't have to rewrite them. I'm just doing them here because I want to show you without having to scroll up and down. So now we're going to do the opposite. So we're going to do g of f of x. And g of f of x, remember, so g is on the outside and f of x is now on the inside. Well, what's f of x? It's simply x plus 1. So it's going to be g of, so I'm going to put that in brackets. I'm going to use red this time. So here's x plus 1. So I'm going to put x plus 1. Well, now we have to go to g. Well, g is this entire thing. So instead of x this time, I have x plus 1. So what that means is anytime I see an x, I'm going to replace it with x plus 1. So this x here will be replaced by x plus 1, and so will this x. Unfortunately, this 4 doesn't have an x, so we don't have to replace anything. We just keep it as is. So if we had to rewrite it, then this is going to be 2. I'm going to put a blank, as I did before, and I'm going to put square because that variable is squared, plus 3. And I'm going to put another blank here because I'm going to replace that x, and then plus 4. Well, what am I going to put in these blanks? Well, it's simple. It's x plus 1, and it's x plus 1. Now, if we scroll a little bit further, now what we have to do is, you can leave it like this, but I'm going to expand it because I want one nice simple expression. Well, first, we're going to expand this. So what does this mean? This simply means 2 times x plus 1, and since it's squared, it's x plus 1 twice, plus 3 x plus 1 plus 4. Now, if you observe over here, since you have 2 expressions, you have this times that, we're going to have to use FOIL. We're not going to multiply the 2. We're going to FOIL it out with simply these, and then at the end, we're going to multiply by 2. So we're going to leave the 2 out there. So x times x, well, that's x squared. X times 1, well, that's 1x. 1 times x, well, that's another x. And 1 times 1, that's simply 1. I can expand this right away because this is 3x plus 3. And then finally, I'm going to add plus 4. Now, I can simplify this just a little bit. So I'm still going to leave the 2 in brackets. It's going to be x squared. Well, what's x plus x? That's 2x. And what's plus 1? Well, that's simply 1. This is 3x. There's no other term over here, so that remains 3x. And what's 3 plus 4? Well, that's 7. Now what we're going to do is distribute the 2. So we're going to multiply each of these terms with 2, or by 2. So it's 2x squared plus 4x, because 2 times 2x is 4x. And then 2 times 1, well, that's 2. And then let's not forget these. This is plus 3x plus 7. Now, let's just combine the like terms. So x squared, well, there's no other x squared, but I definitely see a 4x over here. And I definitely see a constant here, which is 2, and another 7 over there. So we're going to add those terms up. So let me do that. So it's 2x squared, 4x plus 3x, that's plus 7x. And then 2 plus 7, that's 9. And we're done. So in other words, in this case, g of f of x, this was a little bit lengthy, but the final expression is 2x squared plus 7x plus 9. In the next video, I will show you one more example of composition of functions.